morning, evening, afternoon, I don't even know what it is. So it just depends on when you're watching this. This is our second lesson, but it's follows along. This is chapter 2.7, graphs of rational functions. So graphs of rational, what are rational functions? Well, don't forget, rational functions are those that have a variable in the denominator. Man, I already forgot. So that has a variable in the denominator. So, but there's some guidelines for graphing rational fractions that we need to know first. First thing you're going to need to know, first off, is that here are the definitions. Remember, rational fractions has something in the numerator divided by the denominator. These are polynomials. The first thing you always want to do is simplify the problem as much as you can. Make it easy. That's all it is. When we go to graph, we want to find and plot the y-intercepts. Makes sense? We need to find the zeros of the number. Another way of saying the x-intercept. The zeros are the x-intercepts. The vertical asymptotes we'll find by using the denominator. We'll need to find the vertical asymptote. We'll need to find the horizontal asymptote, and we'll use the leading coefficients to do this. And we'll show this example as we work it by putting down all the guidelines first. You need to plot at least one point beyond each x-intercept and vertical asymptote. What that means is your graph's going to be divided into sections. We need to figure out which section to graph. And you'll see as we do this, but these are the guidelines. And pretty much we're going to draw smooth curves. We're going, well, you have all these nice things up there. You'll see as we do these examples. And so without any further ado, here we go. How to actually sketch one using these guidelines. First off, we have this problem here. Sketch the graph of 3 over x minus 2. This is one of the more simpler graphs. And so therefore there's not really anything to simplify on this one. But the one thing I do want to do is this. I'm going to go ahead and rewrite this. There is no x in the top, so I'm going to write 0x. There's a reason for this. When we come up with something here, it will help us out. So notice that there was no x. I wrote 0x plus 3 to start with. And I want to find the y-intercept. Here's what's cool about the y-intercept. The y-intercept occurs when your x is 0. If I put 0 in here, that's just like having those two numbers. So guess what the y-intercept is? The y-intercept is basically negative 3 over 2. Because that y-intercept, the x value is 0. If I put a 0 in here, well, 0 times 0 is 0. A 0 in there, 0 minus 2 is negative 2. You have 3, negative 2. The y-intercept will always be those last numbers without any x's on them. That's what the y-intercept will be. That makes it really easy to find. So I know the y-intercept is at negative 3, 2 on this one. I want next need to find the x-intercept. Coach Stoney, how do I find the x-intercept? I'm glad I asked myself that question so I could explain it to you. That's my best humor today. You find it by setting the numerator to 0. That has to be 0. So what I'm going to do is this. I go 0 equals 0x plus 3. Well, 0x is the same as 0. Does 0 equal 3? No, it does not. So therefore, there is no y-intercept on this particular problem. There is no, there's no x-intercept. There's no x-intercept on this problem. This was a little one unique, but there's no x in the numerator. Therefore, there is no x-intercept. So there's x-intercept is none. The next thing I want to find is the vertical asymptote. How do I find the vertical asymptote? By setting the denominator equal to 0. So I'm just going to go 0 equals x minus 2. Solve for x. X will equal 2. So therefore, the vertical asymptote occurs at x equals 2. The next thing I want to find is the horizontal asymptote. Now here is why I wrote down 0x right here. This is the whole reason why I put that 0x in there. Because in order to find the horizontal asymptote, you have to look at the leading coefficients. And the leading coefficients need to be the same degree. And by the same degree, meaning I need an x and an x. The original problem did not have an x in it. That's why I added 0x. I look at the leading coefficient of the numerator and the leading coefficient of the denominator. The leading coefficient of the numerator is 0, and the denominator is, it's not 0, it's 1. So they had the number 0 over 1. It's a horizontal asymptote, so it'll be a y equals. Horizontals are y equals. And so y equals 0. That's why there was no x-intercept, because there's an asymptote at y equals 0. There's a horizontal asymptote at y equals 0. All right. Now then, Coach Stoney, how do I actually graph that? Glad I asked myself that question again. Now, you got to have a little humor. Here's what we do. I want to graph my vertical asymptote and my horizontal asymptote and my y-intercept. First off, the vertical asymptote occurs at what? X equals 2. Notice I have this nice little line popping up there at x equals 2. I have it nice and red so we can see it. I also know there's a horizontal asymptote at y equals 0. You can actually kind of see that one popping in there, back and forth. All right? And now I also know this. I know there's a point at 0, negative 3 halves. So I'm going to put a dot there at negative 0, 3 halves. This dot tells me I'm going to have lines in this section. Now here's what's really cool. When I go to graph this, I know as an asymptote it's going to get closer and closer to here but never touch. And as it goes up, I've got to go through that point, and yet it's never going to touch there either. So I know there's one here in this quadrant. I don't know whether the other one is maybe over here or over here. So what I need to do is this. I need to pick a point on the right side of the x of this, where this asymptote is at x equals 2. Well, what's the easiest number to pick? Larger than 2 would be the number 3. So I'm going to go put 3 in the problem. 3, that's the original 3. I'm plugging this 3 in. 3 over 3 minus 2. What is 3 minus 2? 1. So it means the answer is 3. So this is actually at the point 3, 3. 3, 3. I put a dot. That tells me my next graph has got to be looking like this here. It's got to be up there and there. So my actual graph will look like the following. And notice how then I kind of hit the points. I'm not real great at this here. But there's my graph. That is the graph of 3 over x minus 2. How did I do it? The y-intercept. Usually if there's an x-intercept, we'll mark it, but there wasn't. A vertical asymptote, a horizontal asymptote, and we have these nice, smooth, curvy lines in each section that will never touch the asymptotes. That's how you graph one of these. That was the basic simple one. All right? It stopped.